Welcome to a deep dive. We've got some really interesting source material here from you, our listener.
We do indeed. And today we're diving into something specific, divisive clustering.
Right. So our mission really is to unpack this. What is it? How does it work? Based on what you sent us.
Exactly. We want to get a feel for its unique approach, how it differs and the core idea behind it all.
Okay, let's jump in. So the sources tell us right away, this is a type of hierarchical clustering.
Which you probably know builds those tree-like diagrams, dendrograms, showing how data points relate.
But this one's different, the direction, right? That seems key.
Totally key. Most people might think of agglomerative clustering, first starting small, merging things up.
Yeah, bottom up.
Divisive is the reverse. It's top-down. Starts with, well, everything in one massive cluster.
Okay. Starts with the whole picture. So how does that work then? If you start with everything together, how do you break it down?
Well, the process, as laid out in the sources, is pretty logical once you grasp that top-down thing. Step 1, you have that single big cluster, all your data.
Everything in the pot. Got it.
Then step 2, and this is crucial, you split that cluster. You break it into 2 smaller subclusters.
Okay, but how do you split it? Is it random?
No, not at all. The split is based on dissimilarity. You essentially find the points or groups of points inside that big cluster that are the most different from each other.
So you look for the biggest fault line, the biggest difference within the group.
That's a great way to put it. You find that maximum internal difference and make your cut there.
Okay. And the sources mention needing a rule for this.
Yes, they emphasize that. You need a specific splitting rule. It's often based on distance measures, ways to quantify how dissimilar things are. It's not guesswork, it's a defined method.
Right, a defined logic, and then keep going.
You do, it's recursive. You take each of those 2 new subclusters and you apply the same splitting rule.
So you split them again, based on their internal dissimilarity.
Exactly, and you keep repeating this, split, 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 each time creating smaller and smaller groups.
Until when?
Well, the sources describe the theoretical endpoint until every single data point is sitting in its own tiny cluster, just 1 point per cluster.
Wow. Okay, so it's like taking a big block and chiseling away, breaking off bigger chunks first, then smaller ones, until you've got just dust, almost.
Yeah, or like your population analogy from earlier, start with everyone split by continent, then country, state, down to individuals. It's about breaking down the structure.
Okay. Now, computation comes to mind. All that splitting sounds potentially heavy.
It can be. The sources definitely note it can be more computationally expensive generally. Finding that best split repeatedly takes effort.
Makes sense. That find the biggest difference step sounds complex, especially doing it over and over.
There's a really interesting twist the sources point out. For very large data sets, divisive clustering can be more efficient than agglomerative clustering.
Really? Faster for big data? How does that work? Seems the opposite of what you'd expect.
Well, the idea, reading between the lines of the sources, seems to be about scope. As it splits, it works on smaller and smaller subclusters, right? So unlike some agglomerative methods that might need to compare loads of individual points early on, divisive focuses its complex splitting logic only within the current smaller group it's working on.
Okay, so the complexity is contained within smaller problems as you go down.
Kind of, yeah. It limits the comparison scope at each step, which can apparently be faster overall when the initial data set is huge. So it's not a simple, always slower story.
Got it. Depends on the scale. And that splitting rule you mentioned sounds absolutely fundamental.
It really is. The sources hammer this point home. You need that predefined logic for how to divide a cluster based on dissimilarity. That's the engine. And defining it well, that's where the complexity and implementation can come in.
Okay, so let's boil down the key idea from these sources. Divisive clustering. It's top down. Starts whole, breaks into parts. Step by step. Driven by finding the biggest internal differences. Powerful, but needs that careful splitting rule.
You've got it. It's thinking about structure by division, not by connection.
So connecting this back to you, the listener, why care about this top-down way of thinking?
Well, it gives you another tool, another perspective, right? Sometimes maybe starting broad and finding the major splits first is more natural for your problem.
Instead of asking which 2 tiny things are most alike, you ask, what's the biggest way to divide this whole collection?
Exactly. Think about maybe organizing a huge library of unknown documents. You might want to find the biggest subject splits first before worrying about individual author similarity.
And the sources hint it might even be faster for really large amounts of information if you can nail that splitting rule.
Right. It's about understanding the trade-offs, division versus aggregation.
Which brings us to a final thought, something for you to chew on. The sources mention implementation complexity and this crucial need for a good dissimilarity measure and splitting rule. So, thinking about real-world data, which is often messy, fuzzy, where defining exactly how different two things are isn't obvious. What do you think is the biggest practical challenge in actually using this top-down divisive approach? Where does it get tricky?
That's a great question to ponder as you look at your own challenges, defining that difference meaningfully.
Something to think about. And that wraps up this deep dive into your sources on divisive clustering.